I can see a yellow button, and there is something
And
happening. Yeah.
yes, indeed, we are live. So
Hello,
welcome
everybody.
to welcome to the November 2019 ENSO seminar. The seminar is going to be given by
Yellow button, and there is something happening. Yeah.
yes, indeed, we are live. There we go. Sorry, just getting my bearings there for a second.
No worries.
Little bit of echo. So yeah, welcome to the November 2019 ENSO seminar. The seminar this month will be given by Dr. Julian Kiverstein from the University of Amsterdam Medical Center.
Yeah.
Julian has been in Amsterdam since about 2011. Is that right?
Yeah, that's right. Yeah.
And you were in Edinburgh before that.
I did my PhD and a postdoc and taught a while in Edinburgh. Yeah.
A good place to be, and just back from Edinburgh as well, actually.
Yeah, it's a beautiful city.
Yes. And there was a good conference there last week. Or was it earlier this week, in fact, was it?
It was. It just finished yesterday on timescales in life and mind. So a very inactive topic.
Good. Excellent.
Yeah.
So I'm sorry I missed that one, actually. I probably would have had I been seen that one coming.
I think you would have enjoyed it. Yeah.
Yeah. It sounds like a really good meeting. We'll have to get more of these things happening online as well to make it easier to sort of join in or sort of keep track.
That's true. Yeah.
Good. So I think at this point we have we're sort of starting to get a little bit of activity. We have one, as I mentioned, Julian, just before we went live, we have one or two people who might be joining us live, and I always give them a minute to show up and bring in, but they may join us later on in the session. And if not, we'll still have a good chat once the talk is finished. So I guess probably at this point, the no specific news from the ENSO community this month. Or not that we've come across yet, but so we will, I think, maybe move straight on to the actual seminar, Julian, if that's all right. So if I invite you to begin your presentation.
Let me just share my presentation. And if I just make this full screen, I think we're ready to go.
Are indeed, yeah.
So thanks to Mark and Matthew for having me. This is a work in progress talk, so bear in mind that it's not all fully worked out yet, and I'm really looking for critical feedback, because I think the argument I'm making is one that is that should be quite controversial for a lot of people that are sympathetic to the inactive approach to cognitive science. So when I finished my PhD, and one of the big things in my PhD was about how phenomenology was critical of computational approaches to cognition, how going back to Dreyfus's critique of AI, there were going to be fundamental limits to understanding cognition in computational terms, in terms of rules and representations. But Dreyfus himself was always open to connectionist approaches to cognitive science, so approaches that tried to think of cognition in more biologically realistic terms, taking the architecture for modeling the mind from some rough organizing principles of the brain. And there's been a lot of excitement recently about the potential of deep learning networks for simulating, modeling intelligence. And I'm going to take up some of that excitement today and think about it from an ecological inactive perspective, and whether we might be able to make sense of how these machines are working, which is really an open question in the science. People are thinking of these machines as black boxes, and finding it very difficult to actually make sense of how they arrive at their decisions, or how to account for the performance of these machines. So that's really an open question. And what I want to do today is suggest that there might be non-representational ways of understanding the performance of these types of networks, and that we might even be able to think of them in ecological and inactive terms. And that's obviously problematic because there's nothing like biological autonomy that these machines are supporting. So they don't have an organization that's self-sustaining and self-producing. They don't have a metabolism, for instance, that would generate any kind of intrinsic norms or purposes. So I'm guessing that a lot of our community will be thinking, well, this isn't going to really take us very far when it comes to understanding the mind, or understanding life-mind continuity, for instance. And so a lot of the same worries that we could find in the work of Varela, Thompson and Roche, and then later on in Thompson's book about connectionism, might still just as much apply today to these kinds of machines. But I want to argue actually that there is something interestingly different going on here that comes out of how these machines are not just self-learning, but also in a sense teaching themselves through action. And I'm going to use AlphaGo as my example of this. And I'll say more about AlphaGo as we go on, but many of you will know about this program because of its beating the world champion Go player Lee Sedol back in 2016, 2017, I think. And I think the question this raises is, well, can we think of AlphaGo as a skilled agent that is actually engaging with the game in the same sort of way as a skilled human agent would, but maybe even going beyond the kind of skilled behavior that we find in human agents? So that's the kind of territory that I want to explore today in my talk. And so here's the kind of classical inactive worries about connectionism, nicely articulated by Evan Thompson in the chapter 1 of Mind in Life. So he worries in that chapter that we could think of connectionism really just as a form of cognitivism. And so what's missing from an inactive perspective from neural network research is that there's no sensory motor coupling with the environment. And so there's no sense in which these networks can really be thought of as doing cognition, understood as sense making, because they're not bringing forth a domain of significance or enacting a domain of significance through their sensory motor coordination. Instead, they're just fed artificial inputs, and then through back propagation algorithms, for instance, by comparing outputs to some solution that they're fed by the designer, the network learns and trains itself up. But really, this is a kind of conception of cognition where it's just a matter of solving a predefined problem using a solution that's actually fed to the network by the designer. So at the end of the day, there isn't really much difference between cognitivism and connectionism. The only disagreement concerns the nature of representations, which are understood as distributed across the network as a whole in the weighted connections between nodes in the network, and the mode of computation, which is not rule-based. It's not applying, carrying out operations on representations according to rules. Instead, it's a matter of processing of these distributed patterns of activity based on the kinds of algorithms that I mentioned already, like back propagation. So connectionism then just amounts to still working within the same kind of cognitivist view of cognition, where cognition is just a matter of representation and computation. And what I want to do in the rest of my talk is consider whether these kinds of worries about connectionism still apply to systems like AlphaGo, so systems that are using a combination of convolutional networks and reinforcement learning to play games like Go at a level of performance that is out-competing world champions. Can we think of them still as subject to the same sort of problems? And you might think at first glance, of course we can. They're still being fed inputs by their designer, and they're still using supervised learning in some sense, and they're still basically doing computation, and so we're still working within a computational theory of cognition, you might think. But I want to suggest that there might be a non-representational, ecological, inactive way of making sense of how these networks operate. And so it's not necessary for us to understand them in a cognitivist framework. But instead, what we can try to do is give a non-representational, ecological, inactive account of how these networks function. So that's what I'm going to be doing in the rest of my talk. And I want to start from something that Ludger van Dijk and I have now termed the usage-based theory of information. So the key idea here will be familiar to many of you who have read the work of Hutto and Mayen. A key argument in their work is that brains, in the way that neurons fire, causally co-vary with states of affairs in the environment. But we shouldn't think of causal covariation in information processing terms if we think of information as a semantic concept, because covariation is just everywhere in the world. There are many different patterns of covariation that can be found. Whereas when we're thinking about semantics or content, the kind of meaning that we're dealing with is a specific kind of meaning that where the meaning can be specified by truth conditions. And you don't get that kind of specificity out of covariation or causal correlation. So neural networks shouldn't be thought of as encoding semantically interpretable information in their neural weights and connections. There's been a lot of discussion in the literature on connectionism, as you all probably know, about how to map patterns of activation in neural networks onto propositional content. But the first move I want to make is just to suggest that we stop trying to take neural networks to be encoding propositional attitudes, but instead think of them as finding ways of adapting to the domain in which they're acting. So ways of acting in the domain of playing Go, for instance, for AlphaGo, and so that the information isn't there encoded in the network, but it's something that the network in some sense brings forth through its activity, something that the network enacts by finding actions that allow the network to perform more or less well in the domain in which it's acting. So information, as I'm going to be characterizing it, depends on its use by a system that are generating actions. And it's only in finding actions that allow the network to perform more or less well in its domain that the that information comes into being, that information comes to exist. But there is no information prior to use. And that's what I'm going to call the usage-based theory of information. So the inspiration for the usage-based account of information comes from Susan Oyama's work, and in particular her book on the ontogeny of information. And a key argument in that book is that we shouldn't think of development as this process of interaction between genes and non-genetic factors that are on the side of the environment, but rather we should think of information as something that only comes about through the participation of genes in a developmental process. So there is no information that pre-exists the developmental process, but rather information only comes to exist in the course of development. And that means that it doesn't really make sense to think of genes as encoding information. And I want to say that the same is true of neural networks, that it doesn't make sense to think of neural networks as encoding information any more than it does to think of genes as encoding information, but rather it's only in the process of acting that information comes to exist. Here I've been influenced by a paper by Rob Witthagen and John van der Kamp from 2010, where they make exactly this move of applying Oyama's account of information to ecological psychology. So what I'm doing here is really trying to make the same kind of move for neural networks, and arguing that exactly analogous points carry across from what we want to say about genes, what we want to say about ecological information, where the notion of information is that there's some kind of specification relation between patterns in the ambient array and structures in the environment, so that perceptual systems are able to pick up on those patterns in the ambient array and thereby detect affordances. And Rob and John are both arguing that we shouldn't think of patterns in the ambient array as specifying affordances in this way, but rather we should think of the patterns as only coming to inform the organism, inform perceptual systems in any way, in the use of those patterns to explore the environment. So similarly, patterns of activity in neural networks don't get to carry information by being encoded in weights and connections, but rather they only get to be information for the network through a process of exploratory action. And so just as we would say for perceptual systems that exploratory behavior has this formative function in determining how perceptual information comes to convey information about objects in the world. So it's only in the exploring that patterns in the ambient array come to be about something, come to be about affordances. Similarly, it's only in the performance of exploratory actions that patterns of activity in neural networks get to convey any information for the network about how to act in a domain like Go. So what's interestingly different, I think, about the neural networks of today, or at least some of them, not all of them, so a lot of convolutional networks, I think, are subject to exactly the same problems that we saw Evan Thompson describing at the beginning of my talk. But there are some networks that are interestingly different, and AlphaGo is a version of this, in that they are exactly performing these kinds of exploratory actions that would allow for, I think, the formation of information that can be used to act appropriately, to perform well in a particular domain. So there's something about exploratory action which I'm arguing allows for distinctions between doing better or worse, and therefore allows for us to make sense of information being information for the neural network. So let me just drill down into that claim in a little bit more detail using the example of AlphaGo and AlphaGo Zero. So what's distinctive about this neural network is that it learns to play Go by playing against itself. And so in the original program, it was exposed to millions of games that people have played in the past. And what it learned to do was predict what would happen in each of those games. And in the latest version of AlphaGo, the program learned, or the network learns to play against itself. So it's not exposed to any games in advance, but achieves performance by playing many, many games against itself, millions of games. And the result of this is that AlphaGo and AlphaGo Zero are able to develop very unconventional strategies that are creative in terms of the moves that are being made. They're so creative that the expert players of Go, that commentators on the game with Lee Sedol, really had trouble in understanding why AlphaGo was making these moves. And I want to suggest that that the learning through self-play, that by playing against itself or by learning how to predict what humans would do, and then using that knowledge to play the game itself, we can think of AlphaGo and AlphaGo Zero as learning through the performance of epistemic actions. So you might know that the notion of epistemic action comes from David Kirsch, whose work in situated cognition. And I want to argue that what's interesting about AlphaGo and AlphaGo Zero is that it's able to learn through the performance of epistemic action. So self-play can be thought of as a form of epistemic action, where what the network is doing is exploring for useful statistical patterns. And those useful statistical patterns, or useful patterns of correlation, just as we saw earlier, come to be information for the network, because the actions that the network is performing are a process through which these patterns come to be information for the network. So initially, the network will perform these epistemic actions that lead the network, the agent, to find useful statistical structure. And that statistical structure comes to be information in the use of that statistical structure. So prior to use, it's not information, doesn't inform the network at all or convey anything to the network. But it's only in the use of that information, in the playing of the game, that the statistical structure comes to be information. And once the network has performed these epistemic actions through exploration, then it can exploit that statistical structure to play the game in performing what are called pragmatic actions by David Kirsch. So how am I doing for time, Marek? Can you hear me?
Yeah, absolutely. Yeah, hi. You've got about 5 minutes left.
Yeah, that's perfect. So I'm getting to the close of it. I want to now just consider a few objections. So one worry you might have about AlphaGo as and this inactive ecological reading that I'm suggesting is just that it's it's making use of networks that that might be thought of as having a kind of classical representational structure, like search trees, for instance. So those search trees, you might think, well, are encoding representations of possible games that the network is then consulting to assign a value to an action policy. So on the right hand of your screen, you can see that the network is made up of a policy network and a value network. And so that the aim is to find the policy that minimizes the difference between an expected outcome, winning the game, and the actual outcome, the outcomes that can be reached from the current position on the board. And you can see that some policies are being given a higher probability or being assigned a higher probability than others by in interaction with the value network, and that then leads to the network selecting one possible move over others through this kind of probabilistic inference. So that all sounds very representation hungry and very against the spirit of ecological psychology and enactivism. But I want to suggest that we needn't read it in that way. So what's distinctive about the use of a search tree, which is what the value network is relying on, is that it involves a form of episodic replay. And this can be thought of in terms of replaying epistemic exploratory actions that allow for the network to find useful statistical structure. And those epistemic actions that are being replayed, that are eliciting this useful statistical structure, I've suggested should be understood in non-representational terms. It's only in the use of the statistical structure that there gets to be any information. So when those actions are replayed in kind of looking ahead in the way that AlphaGo is to select an action that is most likely to lead to the winning of the game, that episodic replay is just making use of something non-representational. And I suggest, following Eric Mayen and Jan Dagenaar, that we shouldn't think that once you reuse something that's non-representational, it thereby becomes representational. It remains non-representational. So what the network is doing here in making use of episodic replay and using these search trees doesn't need to be understood in representational terms. We can still make sense of it in non-representational terms, in the kind of ecological inactive terms that I'm suggesting. So what about the relevance problem? So this is something that I started working on when I was working on Heidegger and cognitive science and Dreyfus's critique of AI. And the worry that that Dreyfus had was that any AI is always going to run into the problem of determining from everything of possible relevance what's of actual relevance, and rules would never allow a system to resolve this problem. So the question is, do neural networks run into the same difficulty? Do they also have a difficulty of working out what's relevant and what's not relevant? Does anything really mean anything for the network? And I'm running out of time, so I can only very briefly respond to that worry. But I want to suggest that self-teaching agents, self-teaching networks do have a way of avoiding the relevance problem, because the epistemic actions that they perform are used to generate useful statistical patterns that become information because they can be used to coordinate to affordances, the affordances in this case of winning the game, or I'm just going to say that's what the affordance is in this particular case. So the useful patterns become information for the network because they become patterns that the network can make use of to coordinate its activity to relevant affordances. The last objection I want to raise comes from Merleau-Ponty, and there's a version of it, I think, also in activism. When we're thinking about self-teaching networks like AlphaGo, we're thinking about a machine, basically, that works through algorithms. And Merleau-Ponty, writing in The Structure of Behaviour, points out that a machine is only really capable of the operations for which it's been constructed. So the idea of a machine, he says, which could be capable of responding to an indefinite variety of stimuli is a contradictory one, since automation is obtained only by submitting the initiation of work, so the operations in the network, to certain chosen conditions. And I think this is absolutely right. So when I gave a version of this talk at Okinawa Institute for Science and Technology, where Tom Fruser now has his lab, Tom and others pointed out to me that AlphaGo is programmed, for instance, with the rules of Go. Now, AlphaGo Zero isn't. It learns how to play the game on its own, but still, it must have some kind of prior that's hardwired. Gary Marcus has written about this, for instance. The drive to win the game. It must know and have some kind of prior knowledge that winning is of positive value and losing is of negative value, so that it can then select the outcomes that are likely to lead to winning. So it seems that the network still has this problem of only being capable of the operations for which it's been constructed. So it's not self-generating, it's not self-producing, it's not autopoietic, and it's not self-sustaining, it's not precarious. So it doesn't have some of the key features of living systems that we would think are necessary for sense making, for anything to be meaningful for the network. And so, picking up on something that De Paulo and colleagues have written in their Sensory Motor Life book, we might worry that there's a kind of openness to skill learning that's missing in these kinds of networks, where skilled agents, unlike agents that make use of reinforcement learning, are able to improvise, are able to coordinate their actions to affordances on the fly in all kinds of indeterminate and unpredictable ways. So De Paulo and colleagues write that what's distinctive of skilled behavior is that the set of all possible patterns of coordination we can't really determine in advance, but rather they are something that emerge fluidly out of the skilled behavior of the agent as they coordinate to affordances. So when we think about development, we are going back to Oyama again, we have to think of each organism as exploring its own unique trajectory in ways that are constrained by its embodiment and situatedness. And this, De Paulo and colleagues argue, allows for something that's really important in skilled action. It allows for skilled individuals to develop their own style and idiosyncrasy in how they engage with the world. I wanted to just finish by suggesting, well, in a way, AlphaGo is also able to do that. AlphaGo is an agent that's curious and creative in the way that it plays the game, because of how it makes use of epistemic actions to explore for patterns of activity that are useful to it, that will help it to do innovative, creative things in the game. And Lisa Dole, commenting on a move in a game with AlphaGo where AlphaGo did something very surprising and something very creative, was, I think, very insightful. He said, "This move made me think about Go in a new light. What does creativity mean in Go?" It made him think. It was a really meaningful move, he said. And I think that that's very interesting, in that it suggests that what AlphaGo was able to do was add something to the tradition of playing this game, something that made Lee Sedol think about creativity in the game in a new way. So I think it begins to make sense to think of AlphaGo as a skilled agent in exactly the way that that De Paulo and colleagues are highlighting here. It seems to have its own style and idiosyncrasy of play, something that puzzles even world champions and commentators on the game. So my conclusion for this talk is that what I've tried to do is argue for an ecological inactive way of making sense of how these networks are able to achieve the level of performance that they do. And I've suggested they do that through making use of epistemic actions. Epistemic actions that allow the network to explore for statistical patterns that are useful, and thereby come to be information for the network because they can be used to play the game well. And those statistical patterns are not information before they're used by the network. They only come to be information in the use, in the performance of the epistemic and pragmatic actions. that allow the network to bring forth a domain of significance, I want to say, that allow the network to coordinate to relevant affordances in an ecological sense. So the upshot of this is that we don't need to hand over this very interesting work that's happening in deep learning and in neural network research to the cognitivists. Rather, what we can do now is give an ecological inactive interpretation of how these neural networks are functioning. Okay, so that's the end of my talk. Let me just come out so I can see whoever is here. Stop sharing.
Yeah. So still me.
Okay. Hello.
Can you hear me okay?
Yeah.
Yeah, perfect. So thank you very much for that, Julian. This there is a heap to consider there. There's some really interesting implications for just the very concepts of an active technology and tool use, I think, which I probably can't articulate questions clearly about just now. But I really like some of the ideas and some of the kind of moves you've made there. I have a host of questions, and I'll be sort of keeping an eye on the YouTube page as well in case there are comments posted there.
Great. Yeah.
So I guess sort of a best place to start is kind of at the center of it all is the notion of basically the information, the usage-based approach to information.
Mm-hmm.
Wraps information up in actions or usage, right? So there's a kind of a use-action complement concept at the center of it. And you didn't unpack that in great detail. So I'm kind of curious as to what you would consider constitutes use for a system. So I guess the criticism of any of these technological systems, computational systems, is in a sense these are tools that are used by their developers, and therefore the usage is proper to the agents rather than the computer scientists really, rather than to the system itself. But you very much make the system the user, and the system being the one performing the actions. So can I get you to unpack that a little bit? Just what constitutes use for, say, AlphaGo Zero as a sample case?
Yeah, nice. So I was trying to argue that it's actually in the playing of the game that any statistical pattern that the network might find comes to be information. So the network is actually well, in the first case, being trained up by through the prediction of patterns of play by humans, and by being exposed to many games that humans have played, then the network is trained up so that it can then play against itself. So the actions are actually the playing of the game, and the statistical patterns that it's finding are patterns that predict how humans would play the game. So that's the initial training up of the supervisory network, or the supervised network. And then once the supervised network has been trained up, then the network begins to play against itself. And it's using the statistical patterns that it's found in predicting human play to play against itself that I think gets you information for the network. So it's the actual self-play that is leading to there being information for the network. And what I was doing there was just taking an idea that we've been developing in ecological psychology, actually, where the issue is about how do patterns in the ambient array get to carry information about affordances. And the classical view was that there's some kind of law-like relation between the patterns in the array and the affordances of the environment that guarantee that the patterns in the array are just are intrinsically informational, because of these law-like relations.
Mm.
And like many inactivists, we're troubled by that. We don't think that there's any information in the array that's intrinsically there prior to use. And so the move was to try to say that the same sort of problem arises for thinking that information is encoded in the neural network. Similarly, information is not just there in the network; it only gets to be there in the use of it, in the use of patterns.
And so, in this case, then the network just doing what it does is it using this information.
The network actually playing the game, so making use of the statistical patterns that it's learned, that it's been trained up with, and this is AlphaGo, not AlphaGo 0, to then play the game, and it's the actual playing of the game Go against itself that I'm saying transforms actually the statistical patterns, which are themselves not information, don't mean anything, are not about anything, don't have intentionality in any sense. They're just patterns of causal covariation, but they come to be information, they come to be intentional through action.
Okay.
Well, this is not your lecture.
This is my lecture.
The joys of the informal setting. So obviously the inactivists are going to get picky around the whole issue of what are these actions intrinsic to the system, I guess, and is there intentionality in the system's actions sufficient to produce or to sort of interpret the finding and usage of the information as the usage of the systems, as opposed to the usage of the developers or the AlphaGo's team, as it were. But I think that's kind of one of those really interesting potential implications, I guess, for a richer ecological reading of something like AlphaGo, in the sense that, if you think of an artist as using their media, so let's just use paint just as the simple example, but an artist exploring with a paintbrush and paint what's possible, and discovering new things about what's possible with paint through the use of the tool in ways that they are incapable of doing without the tool. And then similarly, essentially, the Go community using DeepMind and DeepMind using AlphaGo 0 are exploring Go in a way. And I guess it becomes a question of, well, where's the value in the system? Is there sufficient autonomy and value in AlphaGo itself to say, well, these are actions of AlphaGo rather than extended distributive actions of DeepMind?
I think that's a very important point. So is this just another tool that the computer scientists and the players of Go are making use of, that maybe there is a constituent of our minds in an extended mind kind of way, but doesn't actually have any intentionality in its own right? It only comes to be meaningful in any sense because of how it couples up with us as humans. I think that's a very interesting objection. So what I was thinking was actually that there might be some kind of normativity that comes along in the self-play. So first of all, AlphaGo 0, for instance, isn't given the rules in advance. It has to learn how to play the game without knowing that at the outset. So it has to explore for what counts as the right moves and what moves are permitted, what moves are not permitted by the rules of the game, and that's something that it learns for itself. So there's a kind of normativity there that through its actions it's becoming attuned to, and then is it also or can it also be said to be sensitive to doing better or worse in a game? Well, that's an interesting question, because sometimes it does really crazy things that that the designers described as kind of delusional. It thinks that there are, thinks, if we want to be careful here, it thinks that there are possibilities for winning the game, and it continues to act on those possibilities when really the policies, the prediction of whether a policy is going to win or not, is telling it quite clearly, no, this is going to fail. And yet it seems to overlook that. So the designers describe it as having delusional belief sometimes in the way that it plays. And you might think for that reason that it doesn't really have a sensitivity to doing better or worse. And so, yeah. But I really just see that as part of it being creative. And sometimes when you're being creative, you try stuff out and it doesn't work. Like the painter that you described, that is trying to find their way with a new style, and sometimes they experiment and it just goes wrong and it doesn't work. So I wonder if we might be able to think of these kinds of examples from its performance in the same sort of way, that it is being intuitive and creative in the way that it's playing, just like a skilled agent is.
I guess so. I'm curious, because I don't know AlphaGo Zero or how it operates or how it works sufficiently well. So, in the sense, as I said, the way it's described is that it learns entirely by itself. It is not taught. But how does it learn the rules? So I'm curious as to how it knows when it's made an illegal move. Because in essence, the rules of Go are not a fundamental of the universe that can automatically be abstracted from data. So,
but they are patterns in the way that the game has been played. So
okay, so AlphaGo Zero still has the database of previous games. Is that right?
Yeah, exactly. So it's trained up by being exposed to millions of games that people have played, and predicting finding the statistical patterns in those games. Now, what I was saying was that those statistical patterns don't actually mean anything. They're just mathematical patterns, basically. But once the network starts to actually do something with those patterns in terms of its own play, then I think something interesting happens. That the patterns start to be information for the network in the same way as ambient patterns that you are exploring for in your perceptual engagement with the world become information for perceptual systems when they can be used to coordinate to affordances.
And that's what keeps bringing me around to this notion that in essence the Go ecosystem, that is the community of Go players, have this are now sensitive to patterns through the use of the tool of AlphaGo that they would never have been sensitive to prior. But I'm just, I guess.
So I think, thinking of it of Go as being part of an ecosystem is first of all an important insight, because it then, I think, begins to make sense to see the network itself as a part of that ecosystem, as an active participant in that ecosystem, which is what the network is. It's actually performed against the world champion. The network begins to become an agent, I want to say, even though it doesn't have the metabolism, even though it's not alive. So there's something important missing from an inactive perspective. Still, it is able to participate in the game and do things which are by the light of other practitioners in the game, other experts, other skilled agents. it's able to make very creative contributions, even push the game further in directions that that existing participants in the practice wouldn't have found for themselves.
Yeah. So it may be, I guess, one of the questions that sort of popped into my head while you were describing the kind of neural networks engaged in exploratory action was, I guess, just as to whether or not one of the issues is a difference of intuition about scaling. Now, I think the inactive theory that is kind of principled by sort of autonomous structure and whether autopoiesis or other forms of autonomous dynamics are excuse me, probably not going to accept as you've kind of said, just going to have a problem with the action thing. But there is nevertheless a notion that I get, I think, what you're saying, that AlphaGo and AlphaGo Zero in particular don't fall foul of some of the criticisms of connectionism, sort of other forms of connection, really, that Thompson put forward. Because I thought those other forms don't have, there's not an immediacy in the feedback loop between action and perception, the input units and the output units.
Mm-hmm.
Not the case in these systems, where there is a sort of a fairly direct.
I think there is, there's a perception action cycle.
So it's almost like you've got, you have this something similar, at least, about the dynamics that matter, but it's just a toy version of it. It's a real world for the system. It's just a really simple world. And whether there's still, if we could somehow just set aside the precarity and autonomy issue for a second, is it just essentially taking everything you've got about ecological dynamics, at least, and scaling it down to a simplified system where, look, this is just how this world is. It's not a terribly textured world, but it nevertheless has all of the key dynamics that an ecological approach would want, for example.
Yeah, I also have that worry that it isn't so different from some of the old programs that maybe were able to perform quite well in a particular domain, but they weren't able to do anything outside of that domain. They couldn't transfer their skills to real world situations. And AlphaGo has some of the same, certainly looks like it's subject to the same worry, that it's not in the world. But my reply to that is simply that it is able to do some transference of its skills, because it's able to play other games at a level that beats other programs, for instance. So it plays chess and another Chinese game that I forget the name of, and it's now being used in medical diagnosis. So the same intuitive skills seem to be transferable to other domains. So it doesn't seem to be just operating in a toy world in the same way as GoFi systems were. But there's certainly a lot more to be said about that, because what's distinctive about our skilled behavior is that we're able to very smoothly switch between situations, and we're able to do what's appropriate to each of these situations. So when my wife walked in, didn't really handle it very well. I wasn't particularly friendly. I could have been more friendly, but that was something unexpected, and it was very easy for me to switch from talking with you, Marek, to pointing out no, we're in a lecture at the moment. So this kind of ability to move between different situations, I'm not sure we've seen anything like that kind of skill in artificial neural networks. And so there is still, I think, a worry that there is something artificial about its kind of agency, and maybe But is that to do with biological autonomy and this not being a biologically autonomous agent? Is there something about biological autonomy that gives us that ability to switch between many different situations based on what we care about, what we're concerned with? Maybe, yeah. So maybe, or maybe the best description of AlphaGo and AlphaGo Zero is that they're capable of finding ecological information, but nothing is really relevant for them because they only act in one domain. They only act in a what was Dreyfus's term for this kind of thing? Well, you said toy world already. I think that's quite a good term for it. So they don't really have being in the world in the sense that living agents do.
Yeah. I mean, I guess it's almost the definition of a machine that it is. The relevance is pre-selected. That's that's what makes it a machine rather than something else. Is that someone?
Yeah, and that was Merleau-Ponty's point. But yeah, I mean, I just wanted to respond to that worry that yeah, it's true that there's a lot that's pre-given by the designer, and so that means that the machine is set up in a particular way to be sensitive to certain patterns. But
that's the nature of embodiment too, though.
Exactly, there are constraints that come from embodiment, constraints that come from situatedness. So I'm not sure if that's a relevant difference.
No, excellent. Thank you very much for that, Julian. So I think we're just coming up. We're just under the hour, so this is probably a good place to bring things to a close. But
okay, great. Yeah, thanks for having me.
Thank you very much for that. It was I'm gonna be pondering that one as well. That inactive technology thing is going to stick in my head for a while. So, which is always a good sign, I think. So, yes. So thanks very much for that.
So if people come along later and leave comments, is there somewhere where I can check in for those?
There is. Oh, actually, I've just noticed that there's we'll finish with a question from someone else now. And it's Juan, actually, who's going to be our speaker next month. So Juan, just via YouTube, asks, do you think we need a new category between autonomous living systems and heteronymous systems? So something like self-informing systems or
nice
immediate state.
Yeah. Well, I don't think that these are heteronymous in the same way as GoFi systems were. But nor are they autonomous in the sense of being alive. So in that sense, I think, yeah, it makes good sense to look for something in between. That might be a really good way of seeing my argument. That there are important differences between both your standard kind of computing machine that does things according to rules and representations and biological agents that have cares and concerns that come from their precariousness, because there's no precariousness in these networks. But there's also something similar to both machines that are heteronymous and to living agents.
Yeah, interesting. Okay, so we might end up with a continuum where we thought there was a dichotomy, which is
maybe, yeah. Yeah. Well, I think that's a good point to end on, yeah?
Yeah, absolutely.
Thanks again for having me.
The discussion can continue on the ENSO Seminars webpage. So on ensoseminars.com, each speaker, each presentation has a page, and there's a discussion there. So sometimes there are sort of questions posted after the fact there. So if you're not watching live, a good place to get people's attention is on the discussion forum embedded in the page for Julian's talk. And yeah, so once again, thanks very much, Julian, for your time and for your talk.
And I'll try and come across for Juan's talk next time in December.
Brilliant. Okay, so
yeah, bye bye. See you soon. Bye.